The next several videos will deal with the section 7.3 of the textbook, where we begin our discussion of data structures, which are complex data types that consist of member variables related in some way. These members are, in general, different simple data types, such as the few members of loan data structure shown at the bottom of this slide right here. So loan data structure has loan ID of integer data type, first last name of string, and then there's interest rate, amount borrowed, so forth and so on, all the way to monthly payment of double data type. So the simplest way to think of a data structure is as a relational database table, or table in general, where each member of the table is a column and is in general again of different data type, and they collectively describe an entity, an object, or a thing. So our loan data structure with loan ID of integer data type, name as string, all the way to the MTH as double is one such table. And each row in this table represents a different instance of a single loan, or a different example, different borrower, as the next slide will clearly demonstrate. Okay, so looking at this slide, an array of data structures can be thought of as a collection of table rows right here. 1, 2, 3, and so forth. Okay, composing an entire loan table as shown right here. Each array element, like sample loans of 0, sample loans of 1, sample loans of 2, is an instance of a data structure, and it's stored in the sample loans array, which is of the type loan, which is defined over here on the left. The members of the loan data structure are, as we mentioned a few times by now, a loan ID is integer, name is string, and so forth and so on, all the way to MTH as double. We define the structure, right, this piece of code right here, at the top of the program of the class, or as a class level declaration right at the top of the code, using the keyword structure followed by the name of the structure, loan in this case, followed by the declaration of its members, which are these simple variables over here, and then ending with and structure. Okay, so we declare a structure variable just like a simple variable using a dim statement. Okay, followed by variable name like my loan, and a structure name as its data type as loan in this case. Each of the structure members are accessed by a dot operator or dot notation, typing the structure variable name, so let's say my loan, dot or period, and then choosing the member from a drop-down list like first name, a loan ID, or city, a loan date, amount, interest rate, loan term, loan type, or monthly payment. The members, these guys over here, or all of these, can then be used or are used just like any ordinary variables that receive input with assignment operators, such as these guys here. You can perform calculations on them, such as dividing the amount of loan by the monthly payment and converting the output to string, assigning it to a text variable, and then displaying it as an output in the text box like here. To declare an array of structures, the next bullet down the slide, we do the same thing. That is, we use the dim statement right here, the name of the array, sample loans, followed by open close parentheses, either explicitly specifying the array size, 24 as an upper bound, which is the size of 25 in this case, or by doing it implicitly by reading from a text file, which is briefly discussed at the bottom here. Okay, and then providing the structure name as data type as loan. So dim sample loans of 24 as loan is one such declaration. Okay, essentially defining 25 loans or rows, each with its several attributes or columns defined in the loan data structure. We have 10 of them from loan ID to monthly payment. 0, 1, 2, 3, 4, 5, 6, 7, 8, I guess 9 of them, 10 of them, right? 0 through 9. Okay, so To access the ith loan and its monthly payment, for example, where I would go from 0, 1 to 24, as shown in the previous slide, right? 0, 1, 2 through 24. We would simply use a dot notation just like we did with a regular or ordinary structure variable, and we would use sample loans dot of sample loans of I dot mthpmt or any other, and we would access any other member the same way. As far as reading into arrays of structures from a data file, we will demonstrate this shortly in the payment calculator example. But essentially, you would read the entire file into a temporary array, as you'll see, and then read lines one by one and parse them out into columns. Okay, so to demonstrate the use of data structures and arrays of structures, we will return to our payment calculator project. The initial goal is to read a bunch of loans data into an array of structures of loan data type and display all of those loans or some portion of it in so-called data grid view control, which we'll introduce briefly or in a little bit more detail, but still briefly on the next slide. But it's essentially a spreadsheet like grid format. This particular control is going to be found under the data group in the Visual Studio, and is often used and will be used in database programming, and see chapter 10 down the road, and is relatively easy to work with, as we'll show on this in the next slide. Okay, so now we are going to open up the project, okay, and we'll switch to the FRM payment calc grid form, and we'll notice DGV rather as a data grid view abbreviation, that DGV loans data grid view control that has already been placed on the form. So what we'll do, we'll read loans.txt data into a temporary string array, and then we'll parse it line by line, as I just mentioned, into our loan data structure. We'll use comma as a delimiter. Then we'll filter the data on the type of loan, MORTG for mortgages, as I mentioned here, car for auto loans, and other for anything else, and we'll display then that result in this grid. Okay, so switching to the code, okay, we'll begin at the very top by creating the loan data structure. Okay, we'll declare at the class level, and then we'll declare class level loans array without specifying its size, because we'll do that after we read the data into a temp array, and we'll use the size of that temp array to declare or figure out the size of the loans array of structures, or structure array. So we'll start with the structure keyword followed by loan as the name of our data structure, and then we'll specify each one of these. Loan ID is integer. Then we have dim first name as string, dim last name as string. Then we have dim city as string, dim loan date as date, dim amount as double, that's the loan amount, dim int rate as double, is of course an interest rate, dim loan term as integer is the number of years of the loan, which will differ significantly between car loans, mortgages, and others. Dim loan type as string are these three types of loan: mortgages, auto loans, and the rest. And finally, dim mthpmt as double is our monthly payment. After we declare the structure, again at the class level right here at the very top of the program, we will declare loans array as loan right here. Okay, so this is going to be an array of data structures of type loan, okay, or structure array, okay, essentially representing a table of 25 loans, each loan with these 10 characteristics from loan ID all the way to monthly payment. Okay, so then what we'll do is, as mentioned several times by now, we will read into a temp string array using input output library, file class, and read all lines method from the loans txt file, which is in the bin debug folder of this project. After we do that, we will find the size of this temporary array and then use that size to size our loans array we declared here at the class level. So dim n is integer, is temp.count, okay, which is going to allow us to redim loans with n minus 1. Okay, so now we have our loans array dimensioned or sized up, and we'll create a line string, dim line as string, to read the loans file line by line and store the entire line into that string. And then we'll use a simple data array of size 10 with the upper bound of 9 as string to then parse out individual columns or fields from, again, loan ID through first last name all the way to monthly payment. Okay, so the way the parsing of each line of that loans file into data array is done is by using a simple for next loop, for I as integer, going from 0 to n minus 1. We read for each line into a line string variable. This is the line from the temporary string array. Then we parse it into the data array by using the split method with comma delimiter, as we've done in the previous video. And then for each of the array element, loans I, okay, which in itself is a data structure, each one of these variables, loans of I, okay, is a data structure that consists of those 10 properties, or 10 elements, or 10 members technically. We'll start, they're listed alphabetically as you can see, but we'll go through them in the order in which they were declared to keep it sort of clean, I guess, in that way. So loan ID is the integer of data of 0, right? So the first element of the data array contains load ID. Second one, the first name. Third one, the last name, all the way. The 9th or the 10th really element contains the monthly payment. So loans. So let's see if we can copy paste at least a portion of it. Okay, so I have to type that. First name is data of 1. There is no conversion necessary because it is a string data type. Last name is data of 2. Okay, data of 3, I believe, is the city. So we'll get the city here. Okay, then what's the fourth one? The fourth one is the loan date. The loan date, and the loan date is the fourth one, and it has to be converted with a cdate function. The fifth one is the amount. Okay, so the fifth one is the amount. The sixth one is the interest rate. Okay, and both of these have to be converted into double. Both of these have to be converted into double from string. Okay, then we have the term, which is the int, loan term, which is the int, and it is the 7th data element. We got a few more to go. Loan type. Loan type is the 8th, and it's a string, so there is no conversion. And the final one, Number 9 converted from double is the monthly payment itself. Okay, and that then repeats for every single row of that loans file, right? And we know, from the slide, from the presentation, that there is 25 of those, so it's going to be a 25 rows times 10 columns table. Okay, and it's all going to happen in the load form load event. There is nothing to sort of show right now, so we'll briefly switch back to the presentation, make sure that we are where we're supposed to be, and then we'll take a quick break.